Yeah, so the last thing that I would suggest to do is to calculate this circuit, to do a quick check in the LTspice circuit simulator. So yeah, we have done it with branch current analysis, we have done it with superposition and with nodal voltage analysis, and I think it should not be too complicated to take LTspice. I will try to move it somewhere where I can see the circuit and the values at the same time, and just to repeat the calculation there. So we can set up a new schematic. We can try to find the resistors here. So R1, R2, R3, and R4. And we need to have current sources, and the current sources we find at component, and then they are just called current. And with Control R, you can rotate them and place them here. So then we need to have the wire tool and wire everything together. I will do the outer loop first. And if everything is properly connected, then these soldering pads at the components disappear, but we get nodes, soldering dots at the wire junctions. Then we need to have a reference node. And so here we can use the same as in our calculation by hand. This was wrong. We can go back. Okay. And with space, you can always nicely zoom in and out. So then I could give the sources values. So this is 6 ampere and this is 5 ampere, and maybe I can also rename this to, this is the source 6 and this is the source 5. And the resistors have 10, 20, 30 and 40 ohm. And with this one here, we can also label the nodes and say this here is the node 1, this will be the node 2, and this is the node 3. And so before, if you check this corner here, so this says this is ground, so our reference node. This is the node that I have labeled named 1, this is the node that I've labeled and named 2, and this is the automatic numbering that LTspice uses. So before, this was probably node 001, 002, and 003. So if I also label this with 3, then this is the node 3. And so now we can click run, do the simulation. We want to have this DC operating point, and then we get a result. And then you can see that we get the same nodal voltages that we had calculated in Octave. Yeah, so these are exactly the same values that we had before here. And these are unfortunately in the opposite order. I don't know why. These are the 4 branch currents through the resistors. And so I think they were called branch currents. Maybe, maybe not. Oh no, it was called current vector. So this was the current vector that we calculated in Octave from our branch current analysis, and here it should be the same values but just in the opposite order. So 7.2, 2.2, minus 1.2 and 3.8, which perfectly fits and makes sense. So yeah, you can always use something like this to check such calculations. The disadvantage here in programs like this is that they can of course only give you a numerical calculation, only a calculation with numbers. sometimes you don't know a number yet, or you want to at the end find some formula, what would be the result, how would the result change if I change this resistor. And so here you would always need to repeat the simulation, changing values. So one example or one advantage, for example, of this superposition method that we did here. So here you could also do the calculation just with formulas. So we could have a formula for the influence of the first source. We can have a formula for the influence of the second source. And at the end, we could write down what would be the result for this current just in terms of formulas. And so everything has advantages and disadvantages. Unfortunately, you cannot solve each and every circuit simulation problem by a simulation in LTspice. You can solve many problems, but not all. But this is always a nice check if you have done some calculation by hand to check if it works or not. And in this case, as we have seen, it works. If I once again click on simulate, it works pretty well.